constant volume calorimeter is another way of finding the delta H, or the enthalpy of a reaction. Here's a diagram of a bomb calorimeter or constant volume calorimeter. It's the same thing. It has two layers. This is the outside layer, which is an insulated container. Inside of the insulated container is a layer of water, and inside of that is the bomb, the steel bomb. It's made out of steel, so when there's a reaction that takes place inside of it, in this reaction vessel, the volume won't change, and that's the point of a constant volume calorimeter. This is made of steel, so if a gas is in there and it expands, no work is done because the volume doesn't change. Here's the reaction vessel, and here are the igniters used to initiate the reaction. And again, outside of it here, there's a stirrer to make sure the water is uniform temperature, and here's the temperature. And the whole point of it is I have a reaction that takes place inside. It gives off heat. No work is done. Delta V is equal to 0. So this is going to drop out. So the enthalpy is going to be equal to the change in internal energy, or just the heat basically that's given off due to change of internal energy. And what's going to happen is that this reaction is going to absorb or give off heat, and as a result, the temperature of this water, or whatever medium they have in there, it doesn't have to be water. More often than not it is, because it's very simple. And as a result, when this water changes temperature, the thermometer will go up or down. There will be a change in temperature, and then I will use the delta T times the specific heat. I forgot what the abbreviation for specific heat was. SH is going to be specific heat. And the specific heat of each bomb calorimeter is different. Well, obviously not if they're made by the same company, but in general they have different values. It'll be written on the back or on the bottom somewhere. And then what I do is I look at the change in temperature, I multiply it by the specific heat, and that is going to be equal to the delta H. Very similar to the other calorimetry problems, same idea. I have some kind of medium, it changes temperature, and in this case no work is done, so it's simply just the change in temperature, which is going to be equal to the enthalpy, or the delta H. And the enthalpy, again, is the direction of heat flow for some kind of reaction.